Okay, so we're moving on to our second type of transformation. The last couple of days we've been talking about translation, which means just to slide. But when we talk about the second type, which is called reflection, think about where you see reflection in your everyday life. We're talking about like a mirror image. But in math, reflection refers to something flipping, because that's ultimately what a mirror does. It flips the image that's in front of it to reflect it. So let's talk about when you flip something. So if I flip an image and I literally just flip it over like a pancake, okay, does it change the size and does it change the shape itself? No, it stays the same size, it stays the same shape. So it still preserves congruence, which means stays the same size, same shape. But if I flipped it, and we're talking about, think about any shape in general. It's hard to say triangle or circle because they look similar in a lot of the ways. But if I flip something, is it facing the same way? Like, and when you look in the mirror, does your right arm reflect your right arm? Like, I don't know how to explain that very well. But anyway, it flips, which means it does not face the same way. So this is the first time where we see it does not preserve orientation because it turns in some way. Now let's talk about how this applies to math. So we think of the X and the Y axis as our mirrors. So I'm going to use a highlighter to emphasize what that mirror is. So if I look at number 1, this left column here, we're going to do the X axis first, okay? So I'm going to highlight my X axis, and we're going to treat that as the mirror. So if you think of a mirror, it's ultimately flipping over. And again, this is where reflection means the word flip. We're going to flip this image over that mirror, that x-axis. So you think about it, if we were able to, we would fold this in half and we'd lay it on top and we see what that image would be. But we have to know how to do that mathematically. So here's how it works. If I start with letter A, okay, think about how far away A is from my mirror, the x-axis. Well, it's 2 spots away from there, so it has to be 2 spots away on the other side. So that's where A would land. And since it's the new A, remember, we label this with A prime, A apostrophe. Now, where did it land? Well, then my new coordinate would be -1, -2. We're going to do the same thing for B. But B is not the same distance away as A was. So I don't count 2. I have to count 1, 2, 3, 4 spaces because it's 4 spaces away from the x-axis. So 1, 2, 3, 4 away. So there's B. And again, we're going to label it B prime. The coordinate is -2, -4. We'll do the same thing for C. C is also 4 spaces away, so we go 4 spaces away on the other side. Again, I'm just making a mirror image, and this is -3, -4. Then D is 2 spaces away from the x-axis, so we go 2 spaces away, and the new D is -4, -2. Now look at the image that we've made. If we connect those dots, it's the same shape, so it's the same size. That's why it's called preserves congruence. But it flipped, so it did not preserve orientation. And ask yourself this question: does it look like the mirror image? Does it look like it literally flipped over like a pancake? And it did, so I'm done. We're going to do the same thing for number 2. Again, my x-axis is my mirror, so I'm going to highlight that. We're going to start with letter F. F is 5 spaces away from the x-axis, so we're going to go 5 spaces on the opposite direction. And so that ends up being -4, -5. G is 5 spaces away from the x-axis, so 5 spaces away on the other side is 2, -5. H is 3 spaces away from the x-axis, so we go 3 spaces away on the other side, and that's the new H, which is 1, -3. And then J is 3 spaces away from the other side, so we go 3 spaces on that side, and so it would be -3, -3. Now, when it comes time for your assignment today, it may not ask you to do every single point, but always read it carefully and see which one's asking for specifically. Now let's talk about 3. If we look at 3, we're still going to use x-axis as my mirror, but notice that D and E are on one side of the mirror and G and F are on the other. So how this works is D and E are going to reflect downward and G and F are going to reflect upward. So I'm going to show you what that looks like. D is 3 away from the x-axis, so it's going to go 3 below. So that one ends up being 1, -3. E is 3 spaces away, so I go 3 spaces on the other side. That ends up being 5, -3. But what's strange about G and F, or let's start with F, is notice that it's below the x-axis. So the mirror is actually going to be above the x-axis. So it goes in the opposite direction. So think of it like flip-flopping. So this one is actually 7, 1. Same thing with G. It starts below the x-axis, so it's actually going to end above the x-axis. So this is what's called an overlapping image in the mirror, I guess you can say. So it looks like they're just crisscrossing each other, but it's still a reflection of some sort. We don't see this very often, but it may be something you see in geometry in a couple of years. So just something to think about. Now let's shift gears. This time we're going to make the y-axis my image, my mirror. So I'm going to color my y-axis this time. So if I look at, so you have to shift gears on which direction you're going. Since this time my mirror is the y-axis, I know my picture needs to end up on this side. So that's the direction my dots need to go, not up and down. So if I look at x, x is 3 away from the y-axis on the left, so it has to be 3 spots away from the y-axis on the right side. So there my new x is 3, 5. Then y is 2 away from the y-axis, so I go 2 away on that side, and that would be 2, 3. Z is 1, 2, 3, 4, 5 spaces away, so if I go 5 spaces away on that one, it would be 5, 0. And again, when we connect those dots, it's the same exact shape, it just looks like it flipped over like a pancake and is the mirror image of the y-axis. Let's do number 5, same premise, but notice this time the shape is on the right side of the y-axis. That means it needs to end up on the left side of the y-axis, so we're going to go to the left. So M is 1 space away, so I go 1 space away, which is -1, -1. N is 4 spaces away, so I go 4 spaces away on the left side, which is -4, -1. P is 5 spaces away, so I go 5 spaces away on the other side. That's -5, -4. And then Q is 2 spaces away, so I go 2 spaces away on the left side. And so that would be -2, -5. And then if I connect my dots, again, it's the same shape, same size, but it flipped over completely. And it has to be across the y-axis. So always pay attention which way you're going. Now 6 and 3, like I was telling you about, is what if you have dots on both sides? So you have to think about, well, M is going to have to go to the right, and N, P, Q are going to have to go to the left to make a reflection. So M is exactly 1 spot away, so I go 1 spot away there, and that would be 1, 3. N is 1 spot away, but it's going to go to the left, so it's going to be -1, 6. P is 1, 2, 3, 4, 5 spots away, so 1, 2, 3, 4, 5 spots away on that side. That one's -5, 6. Sorry, the numbers are hard to see. Q is 4 spaces away, so I go 4, 1, 2, 3, 4 spaces here. So the new Q is -4, -2. So when I connect those dots, this is just what's considered an overlapping image, because they overlap at some point because of the dots being on both sides of the axis. So again, when it comes to reflection, first pay attention if it says the x or the y-axis, because if it's the x-axis, you have to go up and down. If it's the y-axis, you have to go left to right. So it's a little confusing in that premise.